Hey everybody! In this video, we're going to be talking about solving rational equations. Ugh. So don't forget, rational. All that I'm talking about here is just fractional fractions. Fractional fractions. So essentially, we're going to be solving equations with fractions involved. So there's a few different ways that we can look at these things to help us solve them more easily or more difficultly, depending on what you want to do. So with this first one, solve. It says solve. So I'm going to find the solutions. Yes. And we are going to have to check our work, so make sure you guys take the time and do that, because just looking at this problem, I know I can't divide by 0, so if I get 0 as a solution, that is not actually a solution. So sometimes we'll come out with solutions that are not actually solutions, but we'll kind of see as we go, see if we get any of that. All right, with this one, what I notice, I have a fraction equals a fraction. So the shortcut is if I multiply both sides by x, I have x times x. And then if I also multiply both sides by 6, 6 divided by 6 makes 1, then I will get to x squared equals 12. Well, that looks a lot easier. You guys probably learned this as cross multiplying. Cross multiply, divide, right? So essentially it's the same thing. That's all I'm saying to do. X times x equals 2 times 6. So if we multiply straight across, that is the shortcut. It's called cross multiplication through an equal sign. Because last step we'd have to do here is just take the square root of both sides so that we have x by itself. So we have x equals plus or minus. Don't forget, whenever you take an even number root, plus or minus, so plus or minus the square root of 12. Again, check your answers. So into the original function, I'm not dividing by 0 at any point, so that is my solution. Oh yeah! Moving up. So here, it's a little bit more difficult, but we can still finagle this thing. We can mess with it some. But it's different because I have two fractions on this one side of the equation, so I can't just multiply straight across. But since this is a positive x over 6, I can subtract x over 6 from both sides, because check it out, those have the same denominator. So because those have the same denominator, I can combine them into the same fraction, just like we had just explored in adding and subtracting rational expressions. So I have 1 minus x over 6. And notice I still have the negative 2. That is carrying down from my original equation. So now that I have them set up as fractions, I can cross multiply. So I have x times 1 minus x equals negative 12. I will distribute this x throughout. So I have x minus x squared equals negative 12. So now because I like to have positive x squareds, what I'm going to go ahead and do here is move both of these x's to the other side of the equation. So plus x minus x, plus x squared, and minus x. So I have 0 equals x squared minus x minus 12. Because now we recognize this as something that we need to factor, and it will factor into x minus 4 and x plus 3, such that I have solutions of 4 and negative 3. So now again, look back to your original equation. I have x divided by 6, that'll be fine. 2 divided by x, so here's where you have to be careful. Just like we were stating our restrictions, we cannot divide by 0 at any point. So I know that x cannot be equal to 0 here, but 0 is not a solution. So my two solutions for this one would be 4 and negative 3. Beautiful, so pretty. All right, moving on. Let me get another sheet of paper. Look at that, how fast was that? I'm like Superman. All right, so here we have fractions. We already have them set up as fractions, so let's go ahead and cross multiply. So I have 5 times x squared minus 1 equals 15 times 2x minus 2. Distribute some stuff, so 5x squared minus 5 equals 30x minus 30. And then I'm going to get them on the same side because I have a quadratic function. So I'll have to subtract the 30x, add the 30. So I have 5x squared minus 30x plus 30 and 25 equals 0. So now out of all of this, it's going to make our lives a lot easier if we can go ahead and factor out the 5. Recognize that because everything here is divisible by 5. So factoring out of 5 leaves us x squared minus 6x plus 5. And now this is super easy to factor. So if I have x and x equals 0, multiplies to be 5, adds to be negative 6, so minus 5, minus 1. Still have the 5 on the outside, but it will not affect our solutions. So now from those, we have solutions of x equals 5 and x equals 1. Now go back and check your solutions. So for 5, I have 2 times 5 is 10, minus 2 is 8. So that's cool in that one. 5 squared is 25, minus 1 is 24. So that's dividing by 24 there. So that one's a cool. So now with 1, 2 times 1 is 2, minus 2 would be 0. Well, because in this fraction, 2 times 1, if I substitute 1, 2 times 1 minus 2, that makes 0. I cannot divide by 0, so that is not actually a solution. So my only solution here would be 5. Even if you were to check it in this other fraction, if I have 1 squared minus 1 squared is 1, minus 1 is 0, so since that equals 0, I cannot divide by 0, so again, 1 would not work. So I only have one solution there. These are called extraneous solutions or extra solutions. But essentially, you just need to know that they do not work. All right, moving on. Doing so good, oh yeah. All right, this one is not really a fraction. I mean, you could put x plus 5 over 1 if you wanted to, but I would just work this one kind of the way that you are used to working. I would multiply by x to get rid of your denominator, so that we will multiply this entire side by x. So we'll end up with x squared plus 5x equals 6. And then it's just a quadratic function that we need to move the 6 over, make it equal 0. X squared plus 5x minus 6 equals 0. Factor that bad boy. So x equals negative 6 and x equals 1. Those are both solutions because if I look back at my original, I'm dividing by just an x, so the only thing that wouldn't work is if we had 0 as a solution. Beautiful. Oh, it's so pretty. All right, moving on. Doing good, doing good, doing good, doing so good. All right, here we have multiple fractions. So, and notice, all of the denominators are different. This denominator, these kind of look similar, but they're not exactly the same, so I can't just combine them. But just like when we were adding and subtracting fractions, if I change this denominator, that would be x minus 5 and x plus 5. So I have x plus 5 here. So if I get these all to be the same denominator, I can multiply this one by x minus 5 over x minus 5. And this is 5 minus x. Well, here's a trick that we can pull sometimes. If I multiply by negative 1 and negative 1, that changes this one to minus 2 over x minus 5. So it essentially changes the signs that they are on. And this is still 3 times x minus 5 over x minus 5 times x plus 5 equals negative 4 over x minus 5 times x plus 5. So now the only one that does not have a similar denominator is my middle part. But what I can do is I can multiply it by x plus 5 over x plus 5 so that I have the same denominator. So now I have 3 times x minus 5 over x minus 5 times x plus 5 minus 2 times x plus 5 over x minus 5 times x plus 5 and equals negative 4 over x minus 5 times x plus 5. All right, all that writing, but now check it out. Since we have these two combine into the same fraction now, so that I have 3 times x minus 5 minus 2 times x plus 5, all over the same denominator, equals the other side. All right, so now check this out. Since the denominators are the same, I have all that junk over x minus 5 times x plus 5 equals negative 4 over x minus 5 times x plus 5. Since these have to be equal to each other, then the tops must also be equal for that to be true. So what I can do at this point is actually just take the numerators and set them equal to each other and continue solving my equation. Because now it's only one variable. So I know there's a lot of work, but it makes it a lot easier now. So distribute the 3, so I have 3x minus 15. Distribute the negative 2 minus 2x minus 10 equals negative 4. Combine like terms, 3x and 2x make x, negative 15 and negative 10 make negative 25 equals negative 4. Add the 25 to the other side, so x equals 21. Yeah! All right, so checking it, 21, going back to our original equation, 21 plus 5 is 26, that is not 0. 5 minus 21 is not 0. 21 squared minus 25 is also not 0, so that is my solution. That is probably one of the hardest ones you will see, so don't freak out. It's okay, they're not going to be all that bad. All right, here, I would get the common denominator on my left-hand side. And then, so if we do that, this one needs a 3 and a 3. This one needs x plus 3 over x plus 3. So I have 30 plus 10 times x plus 3 over the common denominator now. So 3 times x plus 3 equals 6. So what I would do at this point, go ahead and multiply on both sides, just like we did in this one. So notice I multiplied by the denominator here to make that equal 1 on that side. I'll do the same thing in this one. So our denominator now is 3 times x plus 3. So if I multiply both sides by 3 times x plus 3, that makes 1 on that side, and times 3 times x plus 3, I can distribute both of those on this side. So I have 30 plus 10x plus 30 equals 18 times x plus 3. Go ahead and distribute that 18 now. So I have 10x plus 60, if I combine the 30 and the 30, equals 18x plus 54. And then combine your like terms, so subtract the 10x to the other side, subtract the 54 to the other side, so I have 6 equals 8x. So that means x equals 6 over 8, so x equals 3 over 4. Sorry. So that is subtracting 54, subtracting 10x. So I have 8x and minus 54 would be 6. Divide both sides by 8. So I have 6 over 8, which reduces to 3 over 4. And again, you'll go back and check this in your original equation. So 3/4. The only time I have a variable that I'm dividing by is in this one. So 3/4 plus 3 is not 0. So that is indeed a good solution. It's so pretty. You put a bow on it and you draw a monkey carrying a beautiful present for his bride. Yes. All right, moving on. Here's a simpler one for you. So we have two fractions, 2x over 5 equals x squared minus 5x over 5x. So I already have this set up as two fractions, so we might as well go ahead and cross multiply. So I have 5 times x squared minus 5x equals 10x squared. I can distribute the 5 to both of those, so 5x squared minus 25x equals 10x squared. And then I would move over the 10x squared. So if we subtract the 10x squared, we have negative 5x squared minus 25x equals 0. And then take out a common term with this. These both have a negative 5x that they are divisible by. So negative 5x times x plus 5 equals 0. So what that means, x equals 0 for that part, and x equals negative 5 from that factor. So that makes 0, that makes your negative 5. Again, go back and check your solutions. Make sure you guys always do this. Don't just assume they're both solutions. So with 0, if I put in 0 for the x's, I'm dividing by 0 right here. 5 times 0 is 0. So that does not work. That 0 solution does not work. If I put in negative 5, 5 times negative 5 is negative 25. So that's cool. That is not 0. So that is indeed our only solution. Oh yeah, doing good. Doing good, doing good. We only got two more. Trying to go fast, I'm sorry. I'm so sorry. All right. Here, again, I would want to get a common denominator so that we can combine these two together. So right now, this is like it's x over 1. If I multiply it by x over x, it becomes x squared over x plus 4 over x equals 25 over 6. So now I can combine these two into the same fraction by making it x squared plus 4 over x equals 25 over 6. And then I can cross multiply, make my life a little bit easier. So I have 6 times x squared plus 4 equals 25 times x. Then distribute the 6, so 6x squared plus 24 equals 25x. I would subtract the 25x to the other side. So I have 6, right pen, x squared minus 25x plus 24 equals 0. And then do we have any common terms we can pull out? We don't, so we're just going to have to think about how we factor this thing. So I'm going to take a shot in the dark. Lucky guesses, maybe. Hopefully. These are no fun to factor, but I know I have to multiply to be 6x squared with my first term, so maybe 3x and 2x. And I'm guessing it's 3 and 2 and not 6 and 1 because this middle term is kind of high, and it's really close to that number there. So now I have to multiply to be 24. They both have to be negative because they multiply to be a positive and they add to be a negative. So I'm going to guess 3 and 8. So if I put the 3 here, that gives me 9. If I put the 8 there, and 16, so 9 and 16, yes! Boom! Is 25. All right, so what we can do now is take our solutions, set them equal to 0 and solve. So 3x minus 8 equals 0, so x equals 8/3. 2x minus 3 equals 0, so x equals 3/2. Both of those solutions work because as I look back at my original equation, the only thing that would cause us an issue is that divided by x, which would mean x cannot be 0. So those are two good solutions. Happy day. Moving on. Don't forget, you guys can rewind, pause, please do, because I go fast. I know I do. Oh, so fast, not so fast. Hey. So here, I would get common denominators on both sides so that we can combine these things more easily. So over here, I multiply by 6 and 6, multiply by 5 and 5. To make these common, I just need to multiply y over 2 by 3/3. So I have 12y, and then this will be plus 10 over the same denominator of 6 times 5, which is 30. Over here, I have 3y minus 1 over the same denominator, which will be 6. So now that I have the common denominator, I can multiply both sides since they are both fractions. So I have 6 times 12y plus 10 equals 30 times 3y minus 1, and then just solve from there. So 6 times 12y is 72y plus 60 equals 90y minus 30. Combine like terms, so I'm going to subtract the 72y over there and add 30 over here. So I have 90 equals 18y. Divide both sides by 18, and we get y equals 5. Again, go back, check your solutions, make sure it works. But as we look back at our original problem, our denominators are 5, 6, 2, and 6. So there's not even any variables in the denominator. So that has to work. All right, sorry this was so long, but I hope it was super helpful. I love you guys. Make sure you practice. Come ask me questions, please, please, please. Don't forget, mistakes are the only way we get better at things. All right, see y'all soon. Bye-bye.